We're all swimming in this ocean of AI that can predict, generate, and analyze things at a scale that's just mind-boggling. But what happens when these incredibly powerful tools start picking up our own worst habits, our own blind spots? Today, we're going past the hype of what AI can do to look at its deeper challenges. And we're going to explore a potential solution that could change everything, not just for technology, but for how we understand the world itself. It's all about causality.
Okay, so here's the game plan. We're going to start with the absolute explosion of AI we're seeing right now. Then, we'll get into the tricky problem of bias. After that, we'll dive into this powerful idea of causality, see how it's already being used, and wrap up with the most important part, the role that we humans play in all of this.
All right, first up, the AI boom. For a while now, the big promise has been crystal clear. What if we could build systems that use massive amounts of data to make perfectly logical, completely impartial decisions?
And the demand for this is, well, it's staggering. Just take a look at this data. From 2022 to 2024, job postings that require generative AI skills have just gone through the roof. And we're not talking about a little bump. We're talking 7 times the growth for engineers, 9 times for jobs completely outside of IT, and an unbelievable 35 times growth for other tech roles. It's obvious. AI isn't some niche skill anymore. It's becoming fundamental.
This whole boom was really powered by one incredible idea, that we could build a decision-making engine that was pure logic, driven only by data and totally free from all the messy, irrational human stuff like emotions and biases. It's a beautiful promise, right? But it runs into one very, very big problem.
So that perfect vision of a purely logical AI, it hits a wall. And that wall is us. You see, the ghost in the machine, it's us. AI learns from this vast ocean of data that we've all created. And that data is basically a giant mirror, reflecting all of our own shortcuts, our own assumptions, and our own biases.
Let's start with a classic, confirmation bias. We all do this, right? You get an idea in your head, and then you go looking for information that proves you were right all along. Well, when an AI is trained on billions of articles and books written by people who do that exact same thing, guess what? It learns to do it too, and it can amplify that bias on a massive scale. And then there's this one, the illusory truth effect. It's a simple idea. The more you hear something, the more you start to think it's true, even if it's total nonsense. For AI models, learning is repetition. So you can see how this gets dangerous fast. If a piece of misinformation pops up thousands of times in its training data, the model is going to learn to treat it as a hard fact.
And this really shows you how tricky it is to fix the issue. Research shows that just slapping a warning label on misinformation, it doesn't really work that well. Sure, it might make you pause for a second, but it doesn't actually make your judgment any more accurate. What does work? Actively debunking it, actually providing the correct information. That's way more effective at not only fixing the error, but also fighting that illusory truth effect.
So it's pretty clear that just trying to clean up the data isn't going to cut it. To really fix this, AI needs a serious upgrade in how it thinks. It needs to go from just seeing patterns to actually understanding the reasons behind them. It needs to learn to ask why.
Think about it. Most AI today is absolutely brilliant at correlation. It's a master at playing spot the pattern, seeing that 2 things tend to happen together. But that is not the same thing as understanding that one thing causes another. Real intelligence, whether it's human or artificial, needs to get at the why. It's about making that leap from just observing what's happening to understanding why it's happening.
And this is where the incredible work of computer scientist Judea Pearl completely changed the game. As he says here, almost everything we deal with is a big, tangled web of cause and effect. He argued that if we want AI to truly think and reason like us, we have to build the tools of causality right into its core.
And the amazing thing is, Pearl didn't just leave this as some lofty philosophical idea. He built a practical, scientific roadmap for it. You can think of this five-step process as the AI's version of the scientific method. It forces the system to define its question, be upfront about its assumptions, and then rigorously test whether A really does cause B. It turns the fuzzy concept of cause into something a machine can actually calculate.
So a key part of this whole framework is this really cool concept called the do operator. Okay, imagine an AI looks at city data and sees that when ice cream sales go up, crime rates also go up. A simple AI might think ice cream causes crime, but the do operator lets the AI run a virtual experiment. It can ask, what would happen to crime rates if I performed a little surgery on the data and forced ice cream sales to stay flat even when it gets hot? By doing that, it can see that crime still goes up with the temperature, and it correctly figures out that the heat is the real cause of both. That's how it learns to tell the difference between a simple correlation and true causation.
Now, I know this might sound a little abstract, but this isn't just theory anymore. It's already out in the real world, having a huge impact. Let's take a look at how this whole causal approach is being put to work as we speak.
And this is serious stuff. These powerful methods are being used in some really critical fields. Take economics, for example. Researchers are using a technique called double machine learning to figure out the true impact of something like audit quality on a company. Or in sociology, they're using these tools to design interventions that might actually work to close social disparity gaps. We've moved beyond just finding patterns. Now we're finding real answers to some of society's toughest questions.
But here's the thing. Building smarter tools, no matter how amazing they are, is only half the solution. The other half, and you could argue it's the more important half, is about us becoming wiser users. The future isn't just about a better AI. It's about a better partnership between us and the AI.
And the great news is we can all start doing this right now, just by changing the way we talk to AI. So instead of asking it to prove that my idea is right, which just invites confirmation bias, ask for the arguments for and against it. Ask it for 3 completely different angles on a topic. Or my favorite, tell it, challenge my assumptions about this. These little shifts in how we prompt can make a huge difference in fighting bias.
And looking bigger, this all calls for a real cultural shift inside companies and organizations. It's becoming clear that you need to invest in data literacy for everyone, not just the data scientists. And this is giving rise to these fascinating new jobs like the data translator. Think of this person as a bridge, someone who can speak both the technical language of data and the strategic language of business, making sure nothing gets lost in translation.
So in the end, this whole causal revolution in AI is really holding up a mirror. As we teach our machines to dig deeper, to go past the surface-level patterns and ask that fundamental question, why? It forces us to do the same thing. Building a future with responsible, helpful AI isn't just a technical challenge. It's a human one.